All right, so here's the key to knowing that we're applying this other theorem. The key to knowing that we're applying the other theorem as opposed to the first fundamental theorem is the d dx in front. Okay, that's how we know. We see this d dx in front. What that tells us to do, according to the theorem, is start with this x up here. Start with where that interval ends on the definite interval. Take that x, substitute in for t in your function. So you've got the cube root of the x to the fourth instead of t to the fourth plus 5. After you plug in, you take the derivative of that part you plugged in. So what's the derivative of x? It's 1. So we tack that on. After that, theorem continues to this part, which now is going to incorporate this bottom piece where this interval is starting for the integral. So that's going to be this -1 right here. You take -1, you substitute in for t. We're subtracting this, so it's the cube root of -1 to the fourth plus 5. After you substitute the -1 in, you take the derivative of that -1, which is what? 0, and you tack that on. So at this stage, we've applied everything we need to about the theorem. Now it's just a matter of simplifying within reason, okay? If we simplify within reason, we've got a 0 over here multiplied to this result, so we know that that's all going to cancel out. You've got a 1 multiplied to this piece, so really all that's left as your answer is the cube root of x to the fourth plus 5. All right, so the key once again to doing these problems, we see the derivative notation in front. We know we're using our second fundamental theorem. To apply that theorem, we start with the x squared up here. We plug in for t, then our function 1 over 8 plus t squared. So when we plug in, we've got 1 over 8 plus, it'd be x squared squared, right? So x to the fourth. What you just plugged in, you take the derivative of. We just plugged in x squared, the derivative of x squared would be 2x. So we multiply on 2x. Now subtract. Repeat the same process. Only do so with respect to that -x squared we're plugging in. -x squared goes in the place of t. It's 1 over 8 plus -x squared squared. So we're squaring a negative. It's going to be positive. It's x squared squared, so it's x to the fourth. And once again, tack on the derivative of this piece you just plugged in. Derivative of -x squared is -2x. We've applied our theorem. If we simplify within reason, we'd understand here as we're multiplying these respective pieces, this 2x would shift to the top, this -2x would shift to the top, and we'd have common denominators, right? So if we're subtracting with respect to those common denominators, we would have 2x minus -2x. So we're adding on at 2x, right? Be 4x over 8 plus x to the fourth. That'd be our evaluation here.